Yo, what's up everyone? My name's Dave and you suck at programming. Alright, today we're going to talk about zombie processes. What are they? How do they happen? How can we make them? And more importantly, how can we make them go away? For some reason, zombie processes are really mystical to people. When people see them, they're like, oh my god, there's zombies in the machine. Like, what are we going to do? Oh my god. Shut up, first of all. Okay, calm down. And let's realize that it's not a problem in and of itself. It's indicative of a bigger problem, but the zombie processes themselves are red herring. They're almost never the problem. When you see a zombie process, you want to go to the parent, all right? A zombie process is not something to be worried about in and of itself, but it is indicative of a bigger problem. And I'm going to illustrate how they work and how to actually create one. We're going to create one today. It's going to be a lot of fun. All right, so let's look. Let's see what we got here. All right, we have a really simple C program. Look at that, not bash. It's C. Let's look at make zombie. We're going to talk about how to make a zombie process. Well, the first thing the C program does is it forks itself. So this takes one process and turns it into two. As you can see, we're good. We do our error checking. Fork shouldn't really ever fail, so we should never really hit this if statement. So let's talk about the if statement that matters right here. Fork is one of the only syscalls that enters once and returns twice. We now have two new processes, a parent and a child. The way to determine if we are the parent or we are the child is the exit code of the fork syscall. So in this case, if the exit code is greater than 0, we are the parent. Why are we the parent? Because we got back the process ID of our newly created child. If we are the child down here, then we can just do whatever we want. We don't have to worry about the parent. So what does this program do? Well, it's really, really simple. If we're the child, we just die. That's all we do. So we forked ourselves, the child dies immediately. The parent is still alive. Now, what a good parent should do is when it forks child processes, it should call wait on the child processes. It should be looking for signals. There's a sig child. It can get a signal from the operating system when one of the children has died, and then it can go actually wait on one of those PIDs or wait on all PIDs, and it can properly wait on the child. What does wait do? Wait signals to the operating system that it's done. It reaps it. It gets the exit code. It causes all the final cleanup to be done. And it most importantly, I guess, frees the process ID up. So now that process ID can be reused by other processes. So what do we do as the parent? In our program, we print creating zombie with PID. So we actually just print this out. This is just for our own benefit. And then we go into an infinite while loop where we do nothing. We ignore any sort of like signals from the operating system. So we ignore sig child. We ignore everything besides for like the kill signals. So we are a negligent parent. We just pause while the child dies. So what happens if we run it? Well, let's run make zombie and fork it into the background. Cool. So now we have the PID of the parent and we have the PID of the child. So what can we do now? Well, we actually have a prompt back because we backgrounded the process. So from here, we can look to see if we have any zombie processes. Just grep for defunct. And sure enough, we have one zombie process. How crazy is that? Well, we have the parent PID, so what can we do? We can do PS tree minus P. That is not what I meant to copy. There we go. Let's actually call PS tree on the child. So what do we have here? Okay, we have, this is our init process. We're on Mac. We have the terminal running, the actual terminal server, our login for Dave. And then we have bash, which ran make zombie, which ran the child process, which is now defunct. So it is the zombie. Now, if you look at this, you might think, oh my God, there's a zombie process. Let me copy the PID. Let me try and kill it. Oh my God, why isn't it dying? Oh my God, I know, I'll do kill-9. This has to work. You idiot. It's already dead. You can't kill it anymore. When you have a zombie process, it is a rotting corpse. And who do you look at for this rotting corpse? You have to look at the parent because the parent is being negligent here. The child died under the parent's watch and the parent did nothing about it. This analogy is getting away from me. But that's what happened here. So we don't care about the child process anymore. It's gone. This does not exist. We just have the accounting information for it left. The parent is the problem. Make zombie is the problem. So if we were to kill make zombie, we can see it's dead now. Our terminal lets us know that it's dead. We can now look for that, what was it, PS tree? And nothing shows up. We can PS EF for, what was it, defunct? Nothing shows up. The grep shows up, but that's it. There are no more zombie processes. So when you have a zombie process, the zombie process isn't the problem. It's the parent that is the problem. That's the thing you need to deal with. So hopefully that illustrated zombie processes for you. Hopefully you guys are less confused after this video.